Hello everyone, welcome to this course. This course is called Biomedical Ultrasound, Fundamental of Imaging and Micromachine Transducers. I am Professor Hardik Jitendra Pandya. I am an assistant professor in the Department of Electronic Systems Engineering at Indian Institute of Science, Bangalore. I am also an associate faculty at Department of Design and Manufacturing at IISc and a visiting faculty at Indian Institute of Technology, Gandhinagar. Along with me, I have my other instructors, Dr. Himanshu Shekhar and Dr. Carla Makado Shekhar. Both are from IIT Gandhinagar. So let us understand what this course is all about and what you will be understanding in this 30 hours. Right. So as the name says, the primary focus of this course is on biomedical ultrasound. That means that we will take and explain you what are the ultrasound technologies. We'll explain you what are different kind of imaging things. For example, ultrasound imaging principles. We'll explain you signal processing, image processing. We'll explain you how macro machine probes are fabricated. We'll also have a lot of lab components in which we will teach you microfabrication, starting from how silicon wafer looks like. Now, surprisingly, a lot of students who attend this course and similar kind of courses, whether it is semiconductor devices or it is sensors and actuators, or a lot of other courses, right, that we learn in our undergrad, we don't get chance to even see a silicon wafer. But here, it is not like that. We want to show it to you how silicon wafer looks like, how we can have different orientation of silicon wafers, what are different techniques in semiconductor devices, so that you can utilize those techniques or technologies to fabricate ultrasound transducers and other transducers similar to ultrasound transducer. So let me show you the wafer, what I talk about silicon wafer, and it's just to show it to you. The way I am showing is not a right way to show, but this is just for you to understand and see how silicon wafer looks like. You see the wafer that I am holding right now in my hand, it is a 4-inch silicon wafer. It is a single side polished or double side polished. You can see, right? You can see some mirror image, and here also you can see the same thing. It is a double side polished 4-inch silicon wafer. Now, students who take interest or who have undergrad in electronics or instrumentation or physics, right? Can one of them tell you or can understand whether it is N type or P type? It is 110 or 100. You may or may not be able to understand, right? How you can identify different orientation of wafers is also part of this course. Then your oxidation techniques, then how to perform PVD techniques. PVD stands for physical vapor deposition. Then we go for CVD techniques, chemical vapor deposition, etching, micromachining, bulk micromachining, surface micromachining, lithography. We look at the photolithography, UV lithography. Using all these techniques, we can fabricate not only the transducers, which are biomedical ultrasound transducer, which we call as a piezoelectric micromachined ultrasound transducers, but also several other devices. I am holding lot of different sensors in my hand, right from here, 4 sensors. The first one that you see is a gas sensor, force sensor. Then we have here is a interdigital electrodes. We have microneedles, right? We have again IDEs. Then here we have a bioresorbable sensor. So a lot of sensors that I am showing it to you, you will be able to fabricate at the end of course, right? But the focus would be how to fabricate ultrasound transducers, how to utilize this ultrasound transducers, and particularly what are the ability to analyze and integrate transducer effectively with different electronic modules. Now let me come to the next point, that what are the prerequisites for this course. The prerequisites in terms of education qualification, any UG student from 3rd year onwards can take this course. We also welcome electronics students, electronics communication students, instrumentation students, physics students, even doctors can take this course, because the focus is on developing an ultrasound system and to apply it in biomedical domain, right? So MBBS can take this course. Now you will also be interested in what are the companies that may be interested in such kind of skill sets, right? So we can talk about MathWorks, we can talk about OpenBCI, Philips, Siemens, GE, Samsung, Fujifilm, Canon, Verasonics. Many companies are looking for participants or engineers who have expertise in similar domain, right? So that is what course is all about. 15 hours of course will be taught at IISc, 15 hours of course will be taught at IIT Gandhinagar, and at the end of course I'm sure that you will enjoy the learning, learn new skills right from fabrication of different devices including transducers and the two ultrasound transducers. But not only that, you will also look at how to integrate those transducers along with different electronic modules, and what are different kind of laboratories, experimental laboratories that we have, how to utilize those laboratories. We have a lot of recordings for the lab. And finally, understanding that once you have the data, how to convert those data into different kind of images. What are different kind of scans? For example, what is B mode, right? Suddenly there is a question that, okay, if you have a data, how can you convert data into image, right? Because finally, if you understand ultrasound, for us ultrasound is nothing but this fetus monitoring, right? You take ultrasound transducer and you place it along with gel and see some image. But how does it work? How this reconstruction of image happens? This all will be covered in this particular course. So I'm sure that at the end of this course, you will learn new things, new skills, and enjoy this program as much as we do enjoying teaching you all. So welcome to this course, and happy learning.